Welcome to another work solution that's been requested. This is question 10 from the May 2014 Time Zone 1 Paper 1. Okay, and our first part of our question has been to fill in this table here. So we've got xn, we've got an. Xn represents the length of the sides which are created when we insert another square inside of the greater square here. So here we've got one square inside, so the xn represents the length of the side of the triangle that it creates. Now what we need to find is the length of the side of the new triangle which is created when we have two squares inside of our main square. So we've got our first square here, and then we have two squares. This is the second square which is inside of our main square. And what we're trying to find is the length of this side here. Okay. Now we know that the length of the first one is 8. All right. And we can see that it's 8 because the total length side is 16. So 16 divided by 2 will give us 8. So we know that this is 8 here. So we need to figure out the hypotenuse of this triangle here and halve that hypotenuse, and that will give us the side length there. So if we go back to our friend Pythagoras, Pythagoras tells us that the square of C is equal to the square of A plus the square of B. In this case, our sides are going to be 8 and 8. Okay, so C squared is going to equal to the square of 8 plus the square of 8. But we're not trying to figure out C squared. We want to know what C is equal to, which is our hypotenuse. So C is going to be equal to the square root of 8 squared plus 8 squared. That's 64 plus 64, which is the square root of 128. Okay, now if we simplify that, we can break this down. 128 divided by 2 is going to be 64, so this is the same thing as saying, this is equal to the same thing as saying the square root of 64 multiplied by the square root of 2, same thing. Okay, so that simplifies to using our third laws, that square root of 64 is 8 roots of 2. So that's the hypotenuse, and that gives us this whole length here. But we need to know that length, we want to know half of that. So I'm going to divide that by 2. So our x2 is going to be equal to 8 roots of 2 divided by 2. And if we simplify that, that's going to be 4 roots of 2. So the length of this is 4 roots of 2, and we can fit that in here. 4 roots of 2. Now you've been told to copy and complete. Do not write on this page, so you'll have to create your own table in the answer booklet. All right. Okay, so that's half of part A. Half of part A done. And we finally got this one here. Now let's have a look at the second half of part A, and we'll use blue flavor. All right, so for the second half of part A, we need to fill in this third one here. Okay, so we're talking about this diagram here, and we're talking about the area of that triangle. All right, so we have the area of our first triangle here, and then we have the area of our second. Now we're looking at the area of our third triangle. So let A denote the area of each new triangle. Now what we recognize here is that we actually have a geometric sequence. Okay, we have a geometric sequence. So now AN is actually geometric sequence. All right, and if you have a look in your formula booklets, you'll see that the general rule for any geometric sequence, okay, to find any term, is going to be equal to un is equal to U1. U1 represents the first term, multiplied by R, which is the ratio, okay, to the power of N, which term we're talking about, minus 1. So in this case here, we can figure out the general rule for this geometric sequence by just substituting the information that we have in here. And we know that the first one is going to be equal to our first term is 32. 32 multiplied by our ratio. So our ratio is got by getting the dividing the terms by each other. So this is going to be 16 over 32. Over 32. Okay, to the power of N minus 1. Okay, so let's just simplify that. So our general rule for this geometric sequence is going to be 32 multiplied by 16 over 13, a half to the power of N minus 1. So all I have to do now is substitute in which term I want. That's the first term, that's the second term. This is the third term, so I just substitute that in. Okay, and I get the third term is going to be equal to 32 multiplied by a half to the power of the third term minus 1, so 3 minus 1, which is 2, okay, which will be equal to 32 over 4, which is equal to 8. So 8 goes in here. And that is the answer to part A. All right. So now let's have a look at part C. Sorry, I said part C, I meant part B. We've done part A, so let's look at part C. Oh, sorry, part B. All right, the process described above is repeated. Find the 8th term. So A6, or the 6th area, the 8th term. We just do the exact same thing as what we did before because we found the general rule for this particular geometric sequence. So we're going to say that we want the 6th term, so U6, is going to be equal to 32 multiplied by 1 over 2 to the power of 6 minus 1. Okay, 6 minus 1 is 5. All right. And that will give us a half to the power of 5 is 1 over 32. So if we multiply that out, we'll end up with 1. So part B was nice and easy because we already had the general term, and the answer to part B is 1. All right, so let's choose another flavour. Let's go with this flavour here. All right, so that was part B, and now let's have a look at part C. Now part C says consider an initial square of side lengths k centimetres. The process described above is repeated indefinitely. Okay, it's repeated indefinitely. We've got a sequence, and the sequence is being repeated indefinitely, so I'm thinking to myself, I'm thinking of an infinite series, okay? The total area of the shaded region is k centimetres squared. Find the value of k. All right, so we've been asked to consider an initial square of side length k centimetres. All right, so let's have a look. Let's draw that square. What does that square look like? Okay, and we have a side length of k. All right, The process above is repeated indefinitely. The total area of the shaded region is k centimetres. Find the value of k. Okay, so we've got a square and then we've got another square inside. So this is going to be repeated indefinitely. So because it's being repeated indefinitely, we're going to end up with an infinite series. Now, if you have a look in your formula booklet, you'll see the formula for the infinite series. So infinite series is represented like so, and that's equal to the first term, okay, over 1 minus the ratio. All right, so now we need to figure out the first term. Now remember, the first term is going to be the area of this first triangle. When we put the first square inside, we need to figure out the area of that first triangle there. So U1, or the area of U1, is going to be equal to half the base times the height, okay? So it's going to be half times the base. Now the base is going to be, because the whole side here is k, so this base here is going to be k over 2 multiplied by the height, which will also be k over 2. Right, that's just our standard area of a triangle. Right, this is to find the area of the first triangle, which is the first term in our series. So if we multiply all that together, we'll end up with k squared over 8. So that is our first term. So let's substitute our first term into our infinite series, okay? So that's going to be equal to our first term, which is k squared over 8, and all of that over 1 minus, and we already figured out above that the ratio was a half. All right. Now we've already been told that the total area of the shaded region is k. So this infinite series here is actually k. Okay, so k is equal to that. So if we simplify that, we'll end up with k is equal to k squared over 8 divided by, okay, 1 minus a half, which will be a half. All right. So, and if we simplify that further, that's going to be, we'll flip that over, and we'll flip that over, make that a multiplication. So we'll end up with 2k squared over 8. Take this over here, we've got some more room. All right. Simplify again. We'll have k is equal to k squared over 4, which we multiply both sides by 4, and we'll end up with 4k is equal to k squared. And then let's make it all equal to 0, and we'll end up with a quadratic. So 0 will be equal to 4k, k squared minus 4k. And then if we factorise this and we take k out, we'll have k multiplied by k minus 4. That's factored. And using the null factor law, we'll be able to see that k is either equal to 0 or 4. All right. Now if we go, it says here find the value of k. We've done that. K is equal to 0 or 4. And there we have our final answer. Okay. Now, if you need any part of this explanation clarified, or you'd like another work solution, please just comment below, and I'll do my best to get back to you ASAP. Thanks for watching, and I'll see you soon.